Now let's look at understanding quadratic inequalities. So we're going to be looking at different inequalities that satisfy different regions of a particular quadratic graph. Okay, so starting with over here, the first one, it says it's just a basic parabola, just drew any random parabola that has the x-intercepts of a and b. Okay, now it says y is greater than 0. If y is greater than 0, it means it's greater than the x-axis, isn't it? Because the x-axis represents y equals to 0. And if it's greater than 0, it represents anything above that, isn't it? So this part will be represented by the yellow parts of the graph, because those are the parts that make y is greater than 0, isn't it? Now, if I want to solve for the x values of that part of the graph where y is greater than 0, then you can see that all these parts represents the points for when x is greater than 0, y is greater than 0, and this part as well. These values of the graph have these x values. As you can see, they correspond to those particular x values. So therefore, the corresponding x values for y is greater than 0 are when these part, which makes x is less than the value of a. So these part are all values less than a, aren't they? So that's why it's x is less than a. And these part are values of x that are greater than b. So x is greater than b will identify those parts of the graph. Okay, the x values for this part of the graph. Okay, so for y is greater than 0, we have two solutions for x, as you can see on our graph. Now, another case is when y is less than 0. When y is less than 0, it must be any part of the graph that's below the x-axis, as you can see, which is represented by the yellow part of the graph. Okay, and if I want to solve for the x values, then I can find the corresponding x values just like this. So it will be all of these x values within these 2 points, right? So therefore, x is going to be between a and b. Or you can say x is greater than a but less than b. Okay, so when y is less than 0, we have one joined inequality, and when y is greater than 0, we have two separate inequalities, as you can see. Okay, so that's all you need to know here. And just before you continue, you should also know that when it's equal to like that, less than or equal to, then these will be coloured in. If it's not equal to, it will be hollow circles. These are some basic information you probably already know. Okay, so just a little bit of information there. So if y is less than or equal to 0, the x's should also be between a and b, so greater or equal to a and less than or equal to b. So you're going to keep that equal to sign all the time. Okay, so that's pretty much it. We'll try to utilize those information in the next few questions. Okay, so let's get started. Question 35 says solve y is greater than 0. So have a look at the graph. The x-intercepts are -3 and 2. What part of the graph makes y greater than 0? Y equals to 0 is the x-axis, so any part of the graph that's above that represents this inequality, doesn't it? So basically this part here, the yellow parts of the graph which are above the x-axis. Now, hope you guys realize why I put those hollow circles. It's because it's not equal to 0, it's just greater than 0, so we don't include these particular points. Okay, as I said before. So if I want to solve for the x values of the values that y is greater than 0, it's greater than, so it's going to be these parts, all these parts, on and on and on. So we have two separate inequalities. It's going to be like this. X is less than -3, so all these parts represent the values of x which are less than -3, and, all x is greater than 2. So all these parts which are greater than 2. So we have two separate inequalities for y is greater than 0. Okay, so it's very, very simple. That's the first question. Let's try another one. 36. Solve y is greater or equal to 0. Okay, greater or equal to 0. So it's basically the same as the previous question, but the only difference is that it's greater or equal to 0. So just like that, we're going to color in those circles because we're going to be including those points. So it's simply going to be the same answer. X is less than negative 3, but we're going to keep that equal sign. So x is less than or equal to negative 3. And this one, x is greater or equal to negative 2. Okay, so x is greater or equal to positive 2. These two are the answers. Okay, so see that slight difference? So question 37 says solve y is greater than 0. So again, figure out which part of the graph is greater or above the x-axis. Okay, because the x-axis represents y equals to 0, doesn't it? So as you can see, it's obviously just that part which is above the x-axis, but I'm going to have these as hollow circles because it's not equal to, it's just greater than 0. Okay, so the points of x that that satisfy this part of the graph are going to be these parts, isn't it? All these values of x correspond to that part of the graph. So it's going to be between negative 2 and 3, just like that. So x is greater than negative 2, but less than 3. And make sure you don't keep that equal to sign, okay? And that's it. So as long as you have the graph, it's pretty straightforward. That's 37. 38, solve y is greater than 0. Guys, I think you can see that if y is greater than 0, it's any part of the graph that's above the x-axis, right? But for this graph, the whole graph is above the x-axis, isn't it? So the whole graph is representing y is greater than 0. So all the values of x are all these values, on and on and on, represent those x values. So because the whole graph is above the x-axis, therefore all real values of x satisfy this graph, or satisfy this region of the graph. Okay, so that was pretty simple because the whole graph was above the x-axis. Okay, so any value of x will satisfy. 39, solve y is greater or equal to 0. Okay, greater or equal to 0. Well, the whole graph again represents y is greater or equal to 0. Because it's equal to 0, we're going to include that particular point on the x-axis as well. Okay, so again, all real values of x. Okay, because the whole graph satisfies it, all values of x will satisfy this particular inequality. Okay. 40, solve y is greater than 0. So it's the same question as the previous question, but the only difference is that this time it's y equals to greater than 0, not greater or equal to. So we're not going to be including that point there, but we are going to be including everything else. So in this particular case, your answer should be written as all real x, but x cannot be 1. Okay, so all the values satisfied except for that particular singular point. So you can write it like this. Okay, all real x except for x equals to 1, or but x can't be 1. Okay, so very simple. Now we want to solve for when y is greater than 0. Greater than 0, as I keep repeating, it means it must be above the x-axis. But in this particular graph, is there any part of the graph that's above the x-axis? No, there's nothing. So in this case, all this part is below the x-axis, which means undefined or no solutions. Okay, there's nothing above it, so nothing satisfies this inequality. So you can just write undefined. Okay. 42, solve y is greater or equal to 0. Now, greater or equal to 0 means any part on the x-axis or above, isn't it? Because it's equal to, we can include those points that are on the x-axis as well, which is only that particular point here. Okay, so the only answer for this one is x equal to 1 because of that equal to sign. Because we can include the points on the x-axis, we can include that point. But remember, there's nothing else above the x-axis, so we're only having one particular answer there. Okay? 43. Solve y is greater or equal to 0. Okay, greater or equal to 0 is on the x-axis or above. And you can clearly see that the whole graph is above 0. So I can say that all real values of x satisfy this inequality. Okay, although there's no points on the x-axis, also are still all values of the graph of x satisfy this inequality because everything is above. Okay, as you can see. So these kind of questions are actually much easier. 44. Solve y is less than 0. Okay, less than 0 is anything below the x-axis. So this part there. And make sure we're not going to include those points, these points. Okay, because it's not equal to. So I'm going to keep it hollow. So therefore the x values that satisfy it must be between this point and this point. So x is greater than -3 but less than 2. Get the pattern now, guys? That's pretty much it. So question 45 says solve y is less than or equal to 0. So again, this time is the parts of the graph that are below the x-axis, and of course including the x-axis as well. Okay, so we're going to be including this part which is below the x-axis as well as these included parts, okay, because they're on the x-axis and we're going to be including those as well. So basically it's going to be x is between -3 and 0, but make sure you're equaling them as well. So x is greater or equal to -3 but less than or equal to 0. Okay, so it's very simple. 46 says solve y is less than 0. Now, again, tell me, is there any part of the graph that is below the x-axis? Obviously not, so none of them are going to be satisfying this inequality. Therefore, it's undefined again, no solutions you can also write. Okay, so just you can identify that straight by looking at the graph, right? And finally, question 47, it says solve y is less than 0. This time, is there any part of the graph that's below the x-axis? Yes, the whole graph actually is below the x-axis, which satisfy this inequality. So therefore, what can you guys tell me? Yes, all real values of x, because all parts of the graph satisfy this inequality, all values of x will also satisfy it. Okay, it's as easy as that. That's pretty much it. Okay, so just remember them, and always remember, or always trying to refer to the x-axis if it's above or below, and don't get mixed. Always consider your equal to sign as well, because if you don't include that when you need to, you do lose marks in your exam.